Class, welcome to our new unit, probability. Before we get to just regular probability, we have a quick little reminder sheet. Alright, so talking about probability. Probability, your answer, if they ask for the probability of something, can only be between 0 and 1. That is it. Alright, if we have the probability of 0, that means it is impossible. It will not happen ever, ever, ever. So like the probability that as a student you will never go to school, or the probability that we are not going to take the SOL this year. That's impossible. We know we're taking the SOL. Okay, or the probability that, let's say, next year in 8th grade you have to take civics. Okay? The probability that you're going to take civics next year now is going to be certain. That is 100% true. Or the probability that soon summer's going to be here. 100% true. The probability that the sky is blue. 100% true. But now the probability that the sky is, I don't know. Let's think. The probability that the sky is pink at midnight. That's impossible, right? Okay? So again, probability on a number line, it's going to be, or just probability of anything, is between 0 and 1. All right? So it's either going to be 0 or 1 or a fraction. Okay? Now, 50% means it's equally likely. So if we're flipping a coin, the probability that we land on heads is 50%. The probability that we land on tails is 50%, which is 1/2 or 0.5. Now, the closer that we are to the probability of 1 or 100, that means the more likely it's going to happen. So if we look at this picture over here, which matches up to the picture you have, looking here, the probability that we pick a blue marble. There's 4 blue marbles out of a total of 5. That's 4 and 5 or 80%. That's more likely to happen because it's closer to 1. But now let's look at a number die. With our number die, it's going to have 6 sides. So the probability that, let's say, we land on a 3, well, there's only 1 3. There's 1 3 out of 6 sides. So that would be 1 in 6 chance, which is going to be about 17%. So that's closer to 0. Okay? So the closer our probabilities to 1, the more likely it is to happen. The closer our probability is to 0, the less likely it is to happen. And then last, if we're looking for experimental probability, experimental is what actually happened. It's not what's supposed to happen, but it's what happened if you did an experiment, meaning you actually flipped that die or you tossed that coin. Okay? Well, to find that, it's going to be how many times that event occurred out of how many times you tried to flip the coin. So how many times you landed on heads out of how many times you flip the coin. But now the theoretical is what should happen. The theoretical for flipping a coin, well, for heads, there's only 1 heads out of 2 outcomes. Okay? All right, let's move on. So, our first set of notes, probability and law of large numbers. Let's take a look. Alright, first off, let's say we are flipping a coin. What is the probability of a coin landing on heads? If they ever just say probability, that is the theoretical. It's what's supposed to happen. So, how many heads are there on a coin? Well, there's 2 sides, and there's only 1 head. So, probability of landing on heads is 1 out of 2. And as a percent, so we divide 1 divided by 2, we get 0.5, which is 50%. Now, let's say we toss that coin 20 times. How many times do you expect it to land on heads? So they're not asking for probability. They want to know how many times. Okay, well, let's think. We would expect it to land on heads 50% of the time. So what is 50% of 20? Okay, or what's half of 20? Because it should land on heads half of the time. Well, half of 20, we would expect it to land on heads 10 out of the 20 times. Guys, this is theoretical probability. It's almost like in theory what is supposed to happen. The theoretical's what is supposed to happen. So it is what you expect to happen. However, when we actually do experiments, if I actually flip the coin, that's not always going to be what happens. Even though it's supposed to land on heads 50% of the time, that might not actually happen. What actually happens is going to be the experimental. All right, so we have this table. It shows the results for Adele tossing the coin 20 times. So if you look, we know we're supposed to land on heads 10 times and tails 10 times. Both of them should be half. However, again, that's not what actually happens when we do an experiment. So experimental probability is what actually happens when you test it out yourself. So if we wanted the experimental probability of landing on heads, we would look at the chart. The experimental means you look at what happened. Theoretical is what's supposed to happen. Theoretical, we would not look here. But if they say experimental, we look at what happened. So the experimental of landing on heads. Well, we landed on heads how many times? 13 out of 20 total times. So it's going to be 13 over 20. We turn that to a decimal. We divide 13 divided by 20. We get 0.65 or 65 hundredths, which is the same as 65%. And again, we need to know our answers as a fraction, decimal, or percent. If it's a fraction, we need to simplify it. That is simplified. Now, we landed on heads. How does that compare to what we expected? Well, we expected to land on heads 10 out of 20 times, but it landed on heads 13 times. So it landed on heads more or less. More times than we expected. It landed on heads 3 more times than what we expected. All right, let's say next, Adele continues to toss the coin. Now it's 50 times, so the total is 50 times. All right, this chart shows what happened, okay, when she actually did it. If they asked for the experimental probability of landing on heads now, well, she landed on heads 26 out of 50 times. But we can simplify that, guys. Both of those are even numbers. That will simplify to what? 13 out of 25. And now what is that as a decimal? It's going to be 0.52 or 52 hundredths, which is 52%. Okay? So as we see, before the experimental was 65%. Now it's 52%. All right, are we closer to that 50%? Yeah, we're closer, but are we at 50? No. So the probability of landing on heads is still slightly more than what we expected. Okay, we expected for it to be 50%, however, we're at 52%, all right? We should have landed on heads 25 times, right? Because that would have been half the time of 50. So we're still a little bit more, but we are getting closer. Which brings us to a law. So the law of large numbers, all right, and your keyword here is law of large numbers. So the more times we do an experiment or the more trials we do, the closer your experimental probability will get to the theoretical probability. So the more times that we flip that coin, the closer we're gonna get to the 50%, what is supposed to happen. Okay, does that make sense? Let's look at an experiment. Okay, so I'm at Shodor. It's Shodor, and I typed in coin toss. So I put in ratio, and let's say we toss a coin 20 times ourselves. All right, so we got that 45% for heads, 55% tails. Let's say we do it another 20 times. All right, now we're at this and this. Let's do another 20. All right, we're at 58 and 41. Let's do another 20. All right, now, what I'm going to do next, I want to do 100. Let's do 100 tosses. If we toss it 100 times, we should land on heads 50 and tails 50. Let's see if that actually happens. All right, so it didn't happen, but we got pretty close. Let's do another 100 to make it 200. All right, still pretty close. Let's keep going. Pretty close. Let's keep going. I wonder if I can do 1,000. Ooh, I can. All right, notice as I did 1,000 instead of 100, I actually got closer to the 50%, 50%. Let's see what happens as we do 2,000. All right, I'm getting closer. As we do 3,000. All right, very, very close. Do you see how we're getting very, very close to that 50% as I do more trials? We're doing more trials. We're getting closer and closer. Okay? Very, very close. And now let's say we go back to just 70 tosses. So look at this. We're at 0.49 and 0.50 kind of, like the decimals. 0.48, 0.41. Or let's say we had done 30. Yeah, not as close. So the more trials you do, the closer you're going to be to that theoretical probability. Okay? Oops, let me cancel that call. All right. Now, but what's important though is even though that's what happened, if a question asked you just, let me move this. If we had a question just asking on the 51st flip, what is the probability of landing on tails? If that's what they asked you, but they gave you all this information, well, guys, did they say experimental? No. Did they say based on what happened? No. If they do not say that, then you ignore this. And the probability would just be, well, the probability of landing on tails, there's 1 tails out of 2. Okay? But then if they said based on what happened, or if they said experimental, then we would use the chart. If they don't say that, though, if they just want theoretical or they just say probability, then we ignore the chart and we do what should happen. All right, let's look at the back. So again, I just kind of said this. They only want experimental if they ask for it, okay? They only want that if they ask for it. If they just say probability, that means theoretical, what should happen. So let's look at these problems. Rihanna rolled a 6-sided number cube, all right, like one of those, 100 times. Our results are here. They want our answers as percents. So the probability of rolling a 1. Guys, does it say experimental? No. So that means they want the theoretical, just the probability, so theoretical. All right, on a number cube, there's only 1 1. So it's going to be 1 out of their 6 sides, so 1 out of 6, which would be 16.6 repeating percent, or if we round, 16.7%, or you can round to the nearest whole percent, 17%. Number 2 was the probability of rolling an even number. Again, it just says probability, so you ignore this crap and we just look up here. Think of the number cube. Okay, rolling an even number. All right, well, the numbers on a number cube are these numbers. And our even numbers would be the 2, the 4, and the 6. All right, so again, it's theoretical. There are 3 numbers out of the 6 that are even. That simplifies to 1/2 or 50%. Number 3. Key word, experimental probability. So now we will look over here at what happened. Well, the experimental probability of rolling a 2. We rolled a 2 20 out of a total of 100 times. So it's going to be 20 out of 100. That simplifies to 2/10 or 1/5. All right, but they want it as a percent, so it's going to be 20%. Okay, number 4, the experimental probability of rolling a 3 or 5. Experimental is your key word. So we look over here at the chart. A 3 or a 5. So we need to look at both the 3 and the 5. We rolled a 3 22 times. We rolled a 5 18. So both of them combined is how many times? 40. So it's going to be 40 out of 100, which is 40%. If you wanted to simplify first, you could have. It doesn't matter though because they wanted our percent. Next up, the theoretical. Theoretical, keyword, what's supposed to happen, so we ignore this. Theoretical of rolling a number that is less than 3. So that means less than 3. So of our numbers again, so less than 3, we have these numbers. Did it say we could equal 3? No. They want it to be smaller than 3, so it would only be those two. So it's going to be 2 out of 6. Okay, which is 1/3 or 33.3 repeating percent. Or 33.3% or 33%, depending on how you round. Okay? The probability of rolling a number that is greater than or equal to 1. All right, it's just probability, so we ignore this. You do not use the chart. You use theoretical. Well, guys, our numbers that are greater than or equal to 1 would be all of these guys, all of them. So that's 6 out of the 6, which is 1 or 100%. It's definitely going to happen. Okay? What I want you to do next is go ahead and pause and go ahead and try the others. When you're done, hit unpause to check your answers. Good luck. Here are your answers for 7 through 10. On 10, it was the probability of landing on purple. Guys, there's no purple here. Another important thing is simplify your fractions. 2/6 is not simplified. 3/6 is not simplified. So your answer would be the 1/3 or and 1/2. All right, very, very important. On number 11, the experimental probability of spinning pink. You look at the chart. This would have been your answer. Either one works. On B, which color had an experimental probability that matches the theoretical? The theoretical probability of landing on any of these colors is 1/4, 25%. So then you find the experimental probability of each color. Experimental of pink, we already have. Experimental of purple is that. Here's the experimental of blue and the experimental of green. So then you had to figure out which one of these matched the theoretical. The correct answer would have been purple. Okay, once you're done with this, go ahead and get checked to move on to the next thing.